No, it's just me. I have to record it and then save the link because I'm not supposed to like share with people to join the meeting for attendance purposes. So this is just like my way of recording it. I'm kind of curious. Yeah, but Kasab didn't want us to put like the recordings on the web course's cloud because that's how it would be. Yeah, so I had to like go onto my own separate thing. Because every single time I record a lecture, I have to record it to my personal Zoom account. And then if somebody comes to me, I share the link to it with them, the recording link. So it's all, doesn't make sense to me, but I just work here. And if I was going to send out the link, like it would be publicly displayed that I was allowing people to attend via Zoom, even though this week it doesn't count. Well, I don't know. My brain is too fried for this. Anyway, I'm trying to see if I can't figure out. So I wonder.
I like verbiage and then always doing the quiz. I was like, whoa, it's telling me that's true. Something like that. I was getting it wrong. So I did it by hand in the quiz and then afterwards
It's not gonna work. A for effort. Okay, y'all ready? Yes, maybe. All right, I'm gonna go with yes. Oh, all right. So, I made a review for today that, well, actually, I'm like kind of reusing a lot of my old material, but it stayed relevant. So I already have one video that's up on YouTube. That's basically the same information. My plan was I was just gonna like rewrite everything and reformat it all, but I don't necessarily have the technology on me to make it visible for you guys for me to do that. So I'm just gonna straight up reuse it. And if you'll have questions, obviously you can answer or ask them. But so I went through. We have, I think there's 3 versions of the test. 2 of them were finalized, and I went through those, made sure everything that I have is helpful for you. Format. Tentatively, it's like 8 to 9 strictly conceptual multiple choice questions. And I say strictly, I mean, there might be like a tiny bit. No, I'm pretty sure in that count, it's just concepts. And then 1 to 2 with basic algebra, that's mostly going to be your finite difference approximations. And then I don't know if you want to consider decimal and binary conversion to be math. It kind of is because you're dividing by 2 and multiplying by 2, but like, and then the last 15 questions, which it should be a total of 25 questions. Well, it will be a total of 25 questions. And the last 15 will be all on your root solvers, and those are math, like almost all math. There might be some conceptual questions like sprinkled in there, but it's math. Yeah, so I'm sorry?
Would you recommend us to study Horner's method?
Horner's method? No, I didn't see it on any of the tests.
Okay.
I would recommend knowing it just in case they throw a curveball in with the last test version. And I can talk about that a little bit. It's deceptively simple, especially if you go to YouTube. Horner's and Raffinis are like synthetic division. it. So yeah, that's an overview of our general format. Oh, and yeah, so the strictly conceptual questions are mostly going to be on number storage concepts, not so much, your solvers or anything like that. So, oh, and also huge thing, if you haven't looked at your formula sheet yet, highly recommend doing it because almost everything you need to know is on that sheet. Almost. The concepts, not as much, and there's no binary, okay, on it. But like the last 15 questions, plus some of the like basic algebra questions, almost all of that information is on the formula sheet, which she's beautiful and we love her. Second exam formula sheet, absolutely useless. Third exam, the final formula sheet is very useful. Not as useful as the first exams, but still very useful. So little hot take there for you guys. Anywho, going back to this guy. Oh, and I don't know if you guys saw, but in the lab resources, I don't think I took a look at the short review who wrote that, but I put up practice problems that aren't answered or solved, and I'll go through them today for you guys. If you want to see the answers, you can. But yeah, the questions themselves are posted onto web courses in the lab resources. So
So that was the same one that you posted. Posted on Demo Practice.
in the Discord, yes, same ones.
Same one?
Yes. Though the solutions, there was a couple that I goofed on. Actually, yeah, there's like one I think I messed up on. And I updated that in my OneNote, which I'm gonna go through with you guys. I don't remember if I updated the Discord documents. So just keep that in mind, I guess. And it's like basic algebra goofs because I forget how to do basic math all the time, like negative signs. Anyway, so to jump into it, can you guys see that or do you need me to zoom in? Yeah, good. Okay. I don't know if like the people in the back could see. So to start off with our concepts of error, there's two main sources of error in everything that we do in this lab and pretty much all numerical methods. The two main are round-off error and truncation error. And like the way you can differentiate between the two is round-off is the result of trying to store too much data in a finite amount of space. And then truncation is the result of cutting an algorithm short. So specifically, like say you need to store, that's a good example. Well, okay, so I say there's a little mnemonic at the end of that line. Taylor the elephant has a trunk. So the error when approximating a Taylor series or storing the result of a Taylor series is mainly going to be truncation error because you can't solve every single term in that massive series because you can only do X number of the first few terms. So by cutting off the last few terms, which may be small and somewhat insignificant to us, it's still a form of error. And that's the biggest one, so it's truncation. Yeah, so that's all on that. There might be like one question. Actually, there is one question. Anyway, on that concept. And then we go into storing numbers. So I highly recommend when you take the exam, when you get to questions about storing numbers, to take a certain procedure about it. So look for specifically what precision it's asking for, and then what type of number. So if it's a real or an integer, those two are like the big key things. And then after that, check for largest and smallest, and then positive and negative. But really read it. I'm sure some of you guys might have gotten tripped up because I know there was a quiz that had these questions. Yeah, so you really don't want to bamboozle yourself by not reading because I know I did that on the first quiz and I was pissed. So be sure to read because there's very likely going to be at least one question regarding these topics about storing numbers. So double precision storage of real numbers takes 64 bits and it's based on an IEEE standard of 1985, which likes to be brought up a lot. I don't think like that part's gonna be asked about. I actually don't even think we ask you how many bits it takes, but it's still cool information to know. And then double precision storage of integers only takes 32 bits. And then this little guy, can I zoom in? I think I have to do that. Okay, these little number lines, I highly recommend knowing. They're very helpful for remembering when we ask you storing double versus single precision. So the largest, let's see, the largest negative number and then the largest positive numbers are going to be in double precision are -10 to the 308 and 10 to the 308 respectively. And then the smallest in double precision is -10 and 10 to the 308 or to the -308. There we go. So if you can remember that, and this is real numbers, specifically these two number lines are real numbers. If you can remember that double precision is 308 and single precision is just 38, that'll help you a lot. And again, pay super close attention because a real would be, so if we ask largest real in double precision, it's going to be 10 to the 308. But if we say the largest integer in double precision, that's this thick boy, the 2 billion? 147,483,647. So make sure to pay very close attention to that and remember which one is which, because it's easy to flip them up in your head and also to just straight up not read. Also, this is and then this section here, I don't remember if we ask you explicitly for it at any point. I know we have on quizzes. And when I took the first exam, it was on there, but I think they took it off over the summer. But it might be put back. So know it anyway. And also note these conditions, the 3 bullet points with the 3 blue bullet points right beneath each of them. For the purposes of this class, they are true, but in the real world, they are not necessarily true. You can actually even see it in Octave that underflow and overflow errors don't necessarily behave in this way. But know that attempting to store a real number smaller than 10 to the -308 in double precision is going to be a non-fatal error, and it resets to 10 to the -308. And when I say non-fatal, it means that it doesn't crash. Now, a fatal error would be attempting to store a real number larger than 10 to the 308 in double precision. So that's a fatal floating point error. And so if it's fatal, the whole program is going to crash and you're going to get an error. Okay, let me double check that real quick. Yeah. I believe for real floating points, actually, sorry? Are you referring to the difference between real and integer? Did you read that part in the last 2 bullet points? Yeah, you'll get different errors depending on if it's a real or an integer. So if you attempt to store an integer larger than 10 to the 308, you'll get a fatal integer overflow error. So there's a difference between floating point and integer, and that's mostly just literally like storing an integer versus a real. But no, specifically these 3 cases are going to be asked about, because I don't think in Saab's PowerPoint he talks about any of the other ones. So if they ask you about any other scenario, that'd be kind of mean, and I'd probably argue for you guys because I don't know, it'd be really harsh and unfair. So those specifically, those 3 would be the possible ones that you could be asked about. And then machine epsilon, you guys remember me talking about machine epsilon? I think I talked about it like 5,000 times. Minimum. Machine epsilon is the smallest value that can be added or subtracted. I say here from 0, but technically it could be added or subtracted from any number as long as it's still distinguishable from that number that you're adding or subtracting from. So you could say add or smallest value that can be added or subtracted from 1, or smallest that can be added or subtracted from 2, doesn't matter. It's still the same concept because it doesn't really matter what the base is, as long as you note that it's the smallest step size between numbers that you can. What's up?
Yeah.
I'm sorry?
But then the line you put for integers 10 to the 38, not 10 to the 3. That's for single stuff.
It's a single versus double precision.
Right.
Right. So, but an integer, it would be, since it's stored in 32 bits instead of 64,
Wouldn't they be different numbers?
it would be. I can't think of it off the top of my head.
Oh, the 32,000.
Let's see. Actually, yeah, it would be, okay, so if you replaced, can I draw with a mouse? Is that a thing that I can do? This is about to be ugly, so.
10 to the 10?
For your sake, we wouldn't ask you in terms of like 10 to the whatever. It would be an integer larger than,
That value.
yeah.
Okay.
Oh, actually, can
Is this everything right?
I? Oh. My little gremlin laugh. There we go. I'll just copy and paste that bad boy. What? No, erase, please, please. Can I? Oh no, I hate it when OneNote does this. What? What? Can I? There we go. Whatever. She's being not very nice to me today, but whatever. Anyway, so yes, thank you for that correction. It would be this 2 billion number is, it would, that's how it would be asked. It wouldn't ask you, what would happen if you tried to store an integer larger than 10 to the 308? It would be, what happens if you try to store an integer larger than 2 billion? Like, we wouldn't ask you it in the wrong way, if that makes sense. But it's still a good point. Okay, yeah, and then I make this point, the single and double machine epsilon is approximately 10 to the negative 38 in single and 10 to the negative 308 in double. It's not exactly that because like slightly below those, like at and slightly below those, or yeah, at or slightly below those would be read as being 0 or stored as being 0. So exactly at them is like kind of a blurred line. So it's approximately close to those, very, very close. And it also technically depends on your machine. What's up?
Is it kind of like an asymptote where like if you get exactly it, you're just gonna, you can't really represent it. Okay.
Yeah, yeah, that's a nice way to do it. Hard to say it. What's up?
How come it's not plus minus? Like, because it's gonna show from negative side. Oh, never mind.
Wait.
I just answered. You ever seen the largest value is 0, right? The largest smallest value.
Yeah, it's that. It's just like an absolute value. It's a step size. You almost broke my brain for a second. It's like, oh no, everything I knew is wrong. No, okay, we're good, we're good. Before I move on from specifically those, the like number storage, anybody have any questions? Okay, cool. So I do my mini Irish jig. Moving on, decimal to binary. So I don't believe you'll be asked to go from binary to decimal, but as long as you know one way, you'll know the other technically. But it's very important to know how to convert from decimal to binary by hand. You will be asked that. You will be given one. So yeah, do need to zoom out. There we go. Okay, so this is my little handy dandy chart. This is how I learned how to convert from decimal to binary. And so I'm assuming you guys at least have a grasp of what it is. You know, the ones and zeros each represent, this is base 2, 2 to the 0, 2 to the 1, as you go left of the decimal, and then to the right, it's to the -1, -2, I think. Yeah. Anyway, so steps are, so say you have a whole number, you modulo the number by 2 repeatedly like this. And if you have a remainder, you have a 1 in that place. And then if you don't have a remainder, you have a 0. And so what I do is I do that over and over and I write it down, but then you have to flip it because you're starting from the higher end, the higher exponent, and working backwards. So if you flip it, you'll end up with, on the right side, you have the smaller one, or wait. What's a good way to, wait, do you guys get what I'm saying before I try to re-explain it again? Okay, because I was like starting to confuse myself because I was trying to find a new way to explain it. But I don't know, it's like, it's pretty straightforward. And then going from a number less than 1 to in, sorry, hold on, let my brain restart for a second. I'm so tired. Okay, so going from decimal to binary with a number that's less than 1, or working with any decimal technically, you do the opposite, so you're multiplying by 2. And if the resultant is a number that's greater than 1, you subtract 1, and in that place you have a 1. And then you take the remainder of that and multiply it by 2 again and see if you can subtract 1. So like I do here, 0.36 to binary, you multiply that by 2, you get 0.72. So in that place, immediately to the right of the decimal, you have a 0. And then you multiply it by 2 again, and then you have 1.44. So you subtract out the 1, put a 1 next, and then you move the 0.44, multiply it by 2, and you just keep going. This one you don't have to flip because you're already going from technically it should be the largest, and you're going from the largest to the smallest exponent of 2. So yeah, that's just like the little easy way to do it. Because I know Kasab, the way he did it in lecture was like, it broke me when he did it. I just sat there staring at the screen. I want to say, didn't you do that in like the first week? Yeah. Because I remember just like staring at it being like, I thought we were gonna do Fluent. What is this? So anyway, that's the easier way to do it. And I was taught this way by a kid who was a CS major. And he was like, yeah, this should have been taught a lot different for the sake of engineers, but it is what it is. And then cool little trick, if you have a number that is a whole number greater than 1, but it also has a decimal, you can do both of those processes. You just separate them. So you do one process with the part of the number that's to the left of the decimal, you do your division. And then for the part of it's to the right of the decimal, you do the way of the decimal, and then you just put the 2 together. And that's it, which blew my mind. I was like, wow, this isn't some like matrix pain. This isn't just pain. So yeah, that's it on binary junk. Does anybody have any questions on that before I move forward? Yes, what's up?
For example, right, you stuff that is they'll ask you for something.
Oh, yeah. We'll say like shopping at 6 decimal places. I'm pretty sure that's the wording that we use. Or we say truncating, I think. 5 or 6, something like that. We won't make you keep going. I mean, like there's technically a rule. I want to say I wrote it on here somewhere. Oh, and do note, an infinite number of zeros can be added in front of the furthest left binary number to the left of the decimal, but not between like your last one and the decimal place. And then same could be added after your last digit to the right. You can add infinite zeros. So like, how could I best explain that? You could turn, so say you have 17 and you convert it to binary. If you were like technically asked to give more digits for that than just 5, you could say like 0, 0, 0, 0, 0, however many zeros you need to add, and then 1, 3 zeros, 1. If that makes sense. And then it obviously goes flipped the other way. I don't think you'll need to use that. There's a chance, but I don't think so. It's just a good thing to note. I'm trying to remember. I thought I did. Oh, that's what it was. That was my point. Technically, the rule is for decimals, you stop once the resultant fractional part is 0, but we wouldn't make you do that because that's mean. And like, what I mean by that is like this little remainder guy is 0. You keep going until the whole thing's 0.
Right.
But that would be mean. We wouldn't make you do that.
But like the last one there, if you multiply it by 2 again, it will give you a 1.
Yeah, and it most of the time, I want to say, actually, hold on. Is that a question? I think it might have been something, don't quote me on this one, because I don't think it's on the test, but I want to say Kasab once said something about integers could never be precisely stored because they're infinite. I think. Or is it that real? Wait. No, I think it's these integers. What's up? Yeah. Okay. Yeah. So yeah, we wouldn't make you keep going on to infinity because that would just not make sense, huh?
My little bomb.
Yeah. Well, no, not even then.
Not even
It's gonna be multiple choice.
Okay.
The whole thing is multiple. Wait. Pretty sure the whole thing's multiple choice. Pretty sure the final might not be. That's what I'm remembering. But I'm like pretty sure the whole thing's multiple choice. The binary part definitely is multiple choice. So, anywho, any other questions before I move forward? Okay, cool. So now we're into our root solving methods. Yay! Not really. So first we'll talk about fixed point form. Fixed point form, super straightforward. What's up?
On the test, we have to like scan our work and then submit it.
Yes. There's actually like a question at the very end.
That says,
Yeah, that's like you have to click it and it's like, I agree to submit my work or I get a 0.
okay.
Yeah. And if you don't, actually I don't really know what happens. If you don't. I think you get a 0. I'm like pretty sure. I don't know if we've ever had somebody not submit their work. We've had people like scan blank pages and we had to be like, really? That's kind of suspicious, don't you think? But yes, you will have to submit your work. You're welcome. Anyway, yes. What's up?
Do you know, are we showing up to class and taking this exam or is it at home?
I think it's online. Yeah, I think you use lockdown browser.
Yeah.
I heard you can be in class for it. Yeah.
If you want, I don't think it's mandatory.
Those sets are so tiny. I'm like, I have to do work and on my computer.
And be next to nasty people.
Yeah.
I mean, I'm just saying. Social interaction couldn't be me. Any other questions about even like format? What's up?
So I take it we won't be able to use like Octave on the exam. We would have to do all this stuff by hand.
That's correct. Yeah, because you're using, I'm pretty sure you guys use lockdown browser. The respond this sort of is called. Yeah. No camera though. I do remember that. Yeah, with the quiz. All of the exams will be like that, which is interesting. But regardless, it's none of my business. What's up? Did somebody have a question?
Yeah, is it open?
Open note?
Yeah.
I don't think so. Just like I'm being recorded, so I'm not gonna say anything. Just be conscious and remember that you have to have work to submit. Is what I would say. Anyway, before I say anything incriminating, so now we're onto our root solving methods, fixed point form. There will be a couple of questions on fixed point. It's really easy though. So you're gonna be given like this guy up here, your equation, your function of x, and you will be asked to put it in fixed point form, which all you're doing is solving for x, and you're setting x equal to your new function, which is technically g of x, but it's the same thing, you just move it around. And depending on what order your function is how many different ways you can find fixed point form. So if you have an x squared, there's 2 different ways that you can find it. Well, actually, there's a plus and a minus. And then if you have an x squared and an x, and there's technically 3, but really only 2. That's hurting my brain. Just know there's multiple ways to do it. And you guys are smart. That's easy. It's algebra. I'm like, even with this, oh, don't be me. The first time I did this example, I made this example. I like totally made it up. And then I did it in front of a bunch of people, like 200 people, and forgot to make the x squared negative when I moved it to the left. Same with the 7x. I forgot to make it negative. And I was like, yeah, be careful with algebra. And somebody's like, yeah, you forgot the negative. I was like, yeah, go math. Yes. So yeah, but that's literally all it is. And then know what indicates a good initial guess with fixed points. That's in your formula sheet too. Another thing in the formula sheet. I tried to be cheeky the last time I gave a review, and I was like, I'm not going to tell you, you should look on your formula sheet, but it's literally just like if g prime of, for g prime, the derivative of your g that you find, evaluated at your initial guess, if it's between 0 and 1 and not equal to 1, it's a good guess because it means it converges. That's it. And don't find g of your initial guess. I had a bunch of people last semester ask me, they're like, oh, but I did the right one. And I was like, no, I did the derivative. Please, please. And that's that. That's all that is. Oh, finite difference approximations. So that is smack on the front, very beginning of your formula sheet. We even like label it for you. We tell you what order the error even is. All of that. It's beautiful. It's straightforward. Does anybody not get it? Because if you don't, I'll explain it. But if you all do, then I'd rather not explain it. Because it's just finding the slope. Cool, cool, beautiful. Wow, I forgot he even put Horner's method on there. What a king. Anyway, back over here. Fixed point, blah, 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 check formula sheet. This is all just like broad stuff. Oh, I think this is when I was taking notes when I was taking the class and I just snatched it. Okay, moving forward, huge point, that'll be a conceptual question. And you might even have 3 questions on this one little green section right there at the top. Your rates of convergence. Know that Newton-Raphson is quadratic unless you have a double root, in which case it's linear. And you'll know what that means, right? When you have a double root. Cool, cool. I mean, if you don't, I'll like explain it, but it's important to note because he was cheeky. Well, I say he, the TAs make the exams. The TAs were cheeky with my semester when I took the first exam, and they gave us a function with a double root, and I didn't even check it. I was like, that's quadratic, and then I missed that question, and I went to my TA, and I was like, I'm definitely right, and I was kind of a butthead about it, and I got put in my place, rightfully so, because it definitely had a double root, and I didn't even think to check. So when we give you the functions, check for a double root, because you will be asked about that.
That means like you have the same like root, like it's there twice.
Yes, exactly. Like you have, if you broke it down and expanded it into whatever
form or whatever.
Yeah, it would be like x minus 2 times x minus 2, double root. So yeah, bisection converges linearly, and secant converges superlinearly. There's equations for this, but you don't need to know them. As step sizes get closer to 0. Oh, yeah, that's a cool point. I don't think we asked you about it, but it's cool to know. As your step sizes get closer to 0, your truncation error decreases and your round off error increases. It's just like a broad statement. You don't need to know. It's cool though. Anyway, bisection method. Okay, I am a big fan of bisection method because when I first learned about it, I was like, okay, that's cool. But then a friend of mine who, you know, CS kid, because I happen to be friends with a lot of nerds, because I am one, was telling me about, like, if you play a number guessing game, y'all played this, right? Where it's like, you have between 0 and 100, guess the number. The most efficient way to play that game is to guess the midpoint every single time. Because it's like, what's it called? It's binary search method. It's like technically what it's called. Computer science kids use that. That's literally all we're doing. Is you're using the theory that you learn in Calc 1 about, like, if you have a function and on one side it's evaluated as a negative number, and on the other side, or like at another point, it's positive. Somewhere along that line, there's a point where you have a root and your function is 0. So using that, you can binary search or literally just check the midpoint every time to see how close you are to the root, and you adjust your parameters based on, you know, what side of 0 you land on. This is like the formal way to find it. So your iterations, you start with your A and your B in the brackets. Your new A is A plus B divided by 2, which is the midpoint. It's the average. And best way to go about this, because we will likely ask you to do like one iteration of bisection method. So you'll start with your base and your function. I would find your newest X and then find your residual and your convergence, and you will likely be asked about all 3. Your residual is the function evaluated at the midpoint, so you like your updated X, and then convergence is the absolute value of B minus A over 2, or your new parameters, high minus low of 2. Technically, you could even do it the other way, because it's absolute value. Doesn't matter. Anyway, and then you update from there. It's pretty straightforward. Yeah, continue until A equals B. We won't make you find the root, I don't think. But this formula, this number of iterations formula is important. I think it's also on the formula sheet. Might be. Actually, let's find out. Because, like, look at how beautiful she is. She gives you so much. She's there for you when no one else is. Otherwise, maybe it isn't on there. Oh, no, wait. Error. Oh, yeah, it is. It's right here. Wait, what? Hold on. B minus A over tolerance. Oh, okay, I see. He just solved it. So, like, if you needed to find your number of iterations, you could plug it in this way, put in your tolerance on the right-hand side and your bounds, and then solve for in. But we even make it easier on you and solve it for in, and you can plug in everything else. And it's even easier, which is pretty cash money. I'm not gonna lie. You're welcome. So yeah, know where that is, or at least know like that it's there. It exists. It's there to help you. And that's it on bisection. Anybody have questions about bisection? No? Cool. Now, Newton-Raphson. Newton-Raphson and secant, I really hope that you guys understand, because we just did projects on that. Bisection, I'd understand if you weren't comfortable with it, but like Newton-Raphson, I mean, come on, man. Conceptually, you might be asked the difference between secant and Newton-Raphson. If you're in my lab, which I think almost all of you are. Is anybody in here not in my lab section? Yeah, I think so. Okay, cool. So y'all know, I've talked about it. I've beaten the dead horse, as they say. The difference between Newton-Raphson and secant is that Newton-Raphson, you have your formula or your equation and your exact derivative and one initial guess. And then secant, you only have your equation and 2 initial guesses, and you replace the exact derivative with a backwards finite difference. That's it. And it's super straightforward. Like the equations look ugly and gross, but everything, I mean, y'all, everything is on that formula sheet. Like, look at this. We give you how to update your iterations of X. We give you how to find residual and convergence, so you don't even mix those up. And we do the same for secant. I don't even think there's going to be the only other thing. Yeah. The only thing that we don't tell you is convergence. That's like the only thing that's not on the formula sheet regarding these guys. Yeah. That's the fixed point. I wonder where you put it at the bottom. Anyway. So yeah, and does he? Oh, okay. I will say, so I will show you one thing. And it is the same thing. Like if you plug in this f prime of x of I in the secant formula sheet into here and you solve for it, what you will get is this much prettier form. Oh, actually, wait. No. Where did you go? This guy right here. Well, both of these technically, but this is, x2 and x3. And it's literally just from plugging it in. So it's your x update equals the previous x minus function evaluated. Wait a minute. Yeah, no, that's right. That's right. I got confused for a second. I was thinking of Newton Raphson with only one guess. Your 2 guesses. So the x2 before it, function evaluated at that x, times x, the previous x minus the x2 previous, over function evaluated at the x before minus the function evaluated at the x2 before. But as ugly as that even sounds, you just plug in, you plug shit in, you got it. Anything else on this? And that, my friends, it's pretty much everything you need to know for the exam. Wow, it's 210. Nice. We're pretty good. Anybody have any questions? I have the exact problems that I can work through too, but what's up?
In the sheet, it was posted back in Discord a while ago. So this is the same one.
The way I posted it's kind of ugly because I had to screenshot this. Because for some reason, OneNote is just, as fun as she is to take notes on, exporting notes is just awful. It doesn't work. Like 9 times out of 10, it just won't even do it. So it's like, okay. I could try to export this again. I'm not gonna lie, I'm really proud of it. She's really pretty. My handwriting is like okay-ish, but at least it's legible. So yeah. Yes, what's up?
So are we gonna have the whole class to do it, or is it like a set amount of time?
I think you get the whole class. Actually, let me check so I don't give you a wrong answer.
During class time.
Yeah, okay, I thought so.
Mhm.
Assignments. Oh, doesn't say. And if I click on it, it's going to show the questions, so I'm not going to do that. Sorry, guys.
You mind scrolling back down to the secant method real quick?
I'm sorry?
Do you mind scrolling back down to the secant method?
Come on.
Right there. Thank you, man.
There we go. Yeah, what's up?
How did you try to export it? Because I use OneNote for everything.
I first tried to use print here. How else did I try? There was another one. Actually, that might have been the only method.
I usually like share it or save it as a PDF.
Oh. How does one do that? I feel like an old
Well, it's
person.
different on desktop, but I guess if you hit share, send a copy of the page. And well, I guess there's not another option on desktop.
What do you normally use?
My iPad.
Oh.
Yeah, and there's an option to like save as PDF.
Yeah, you can do the print as a PDF. That's great for desktop. Hit the page. once you get into PDs.
Yeah, see, that's what I've done in the past, and it'll be like, it can't. So let's see. I'll try it. Printer, Adobe PDF.
Try changing it to pages where it says current page, and then switching it to, it should be like a display.
What happens if I do? Oh God, 50.
Oh, 50 page, sorry, that one below it. Actual set.
Doesn't that make it like blown up? Yeah, no. No, it usually just says like, it'll give me some stupid error about like, we don't have access to this. Let's see what happens. Oh, is it gonna work? No, I'm kind of scared. Wait, okay. We'll just pop it down. That's same one. See if she works this time. Because I was trying to do it on my. It could be just that my Surface is stupid. Because I love her, but I bought her on Amazon for like $400, which is kind of suspicious. But it works. So like, it works most of the time. Most of the time. And that's how I get the most issues. Because I'm only ever in this room on lab times. And I made this at home, I think on like a Sunday night at midnight once. Hello? Do y'all see?
It was
Because
on the quick access.
I had it saved it down. What the fuck? Oh, I see. I see. No? That's weird. Oh well, whatever. If she's there. I wonder. Close Chrome already. Does anybody have any other questions while I'm playing around with the computer? No? Okay. And then I'll show you guys the solutions to the practice problems. I'll just drop this in my main. Oh, file not found. Bitch. Did I say that you could be not found? Last week was that. Okay, it was saying that its location was here, downloads. This PC downloads. She doesn't exist. No, I will not. Okay, do y'all see it or am I, like,
I don't see it.
what is going on? All right, I'll figure this out later. It doesn't really matter. Anyway,
Your comp site, huh?
I'm sorry.
You can talk to your comp site,
I'm sorry.
your computer science one.
Oh, nah, they all graduated, which makes me feel old and sad. I almost did a CS minor. I was very close, but then I decided to do Finite instead. Big mistake. Anyway. So solutions. Is there any like set that y'all want me to like show you? Because I even feel like these are, oh, actually there was one thing I wanted to show you. Bisection, my pro strat in my little note, is write everything down in a table. You don't have to, obviously, but it helped me keep things straight. So, and there's a couple ways you could do it too. I normally did it in order of which iteration I was on, and then plugging in your X and then the function evaluated at that X. And so it helps you see, so if you start with 2 and 4, you've got -7 and 25. Your next update is 3, and that is found to be 1. So you know your new bounds are 2 and 3. And then you update again, and that's -3.875. So now your new bound is 2.5 and 3. But you could also do it so that you have like X of naught at the top and then X of 1 at the bottom. So your A at the top, B at the bottom. Or you could flip it if 1 is negative, that's backwards, and then work your way in. That's up to you. That's just how I did it. Let's see. Did I have any other pro tips? Oh, also Newton-Raphson. I highly recommend when you get started to just make it easier on yourself. You'll be given your initial guess and your function. And you might be given the exact derivative, but chances are you won't be because it'll probably be like a super simple function like 3x plus 7 or some shit like that. So write down your derivative and the function evaluated at your initial guess, and then the derivative evaluated at your initial guess. Write all of that down and like keep it at the top, and that way it makes your iterations easier as you move forward. Because obviously you have to write it down as you iterate, but keeping things organized is very helpful. This is the only class that I actually tried to stay organized in. It's also the only engineering class I've actually liked. Side point. So yeah, anybody have any questions? If you don't, what's up?
You said you posted all these.
I posted the questions, not the answers.
Are we allowed to like we attend the bombs to message you, like send you a PDF of our work and then you check them if the answers are available?
Are you in the Discord?
Yes.
The answers are in the Discord.
Oh, they
Check the resources tab.
are.
Because I'm not gonna lie, this weekend I'm just gonna be an absolute vegetable and lay on the couch all day because I've had a week from hell. Anybody have any other questions?
So the answers from this board are wonky.
There's one.
They should be. Did I update the? Let's find out. Am I signed in on Discord here? Yeah. Oh. I am here. Yes. No. Okay. Whatever. Let's see. Yeah. They should be right. If you come across something that looks, because I think like the one that I got wrong was super. I don't even know. See, the thing is I don't even know if it's my example problems that I had the mistake. I know I had a mistake in my notes, but I fixed that in my notes, and the fixed version is published. But I don't recall if any of the practice solutions were wrong. But if any of them were, it would be pretty obvious. It would be like, I'm missing a negative sign because I don't know how to do basic math. Yeah. Otherwise, y'all are free to go. If anybody, or does anybody have any other questions? It's only 2:20. Let's go. Okay. You may leave. Be free. How did it come? Yeah, you're welcome. I'm so confused. Where is it?
You still trying to find the button?
Like, what?
Is she right now?
Is there any like restrictions on what type of calculator?
I think it is supposed to be scientific. I mean, wait, hold on.
I don't think you said anything specifically for the quizzes though.
The heck, what happened to, oh, wait, hold on, sorry.